let us start. Embedded system definition says like this. So an embedded system, it is a branch of electronics engineering, and it is a combination of both hardware and software designed to perform some specific function. So try to understand the word here. So embedded system is a branch of electronics engineering, and it is combination of hardware and software, and which is designed to perform some specific task. So this is a very interesting interesting thing about embedded system. It is a combination of both hardware and software. So we should have a knowledge on hardware, and we should have also knowledge on software, right? So then embedded system typically contains a microprocessor or a microcontroller, memory, input output devices, and software components. So this is a simplified definition. So what are the components of the embedded system? We'll have software, so we will have a processor inside, we'll have microcontroller, we'll have memory, input output devices, and etc. So these many things will be there in the embedded system. Let us see with a simplified block diagram how it looks like. So as I told you already, embedded system is a combination of both hardware and software. So hardware components nothing but processor, memory, input output devices, and software component is nothing but programming, right? That is what you are seeing here. So this is a simplified block diagram where we'll have a processor as a main circuit, or a processor is going to control all your applications inside the embedded system, and we will have a memory. So in this memory we are going to store the code, and also we will store the data for temporarily. So data and code both will be stored in the memory, and on the other hand we will have a software part. So software is nothing but coding part that we're going to develop. Along with that, we will have a sensors. So sensors nothing but it's a circuit which is going to sense the analog information from the physical world. Like if you take example of your mobile phones, we will use a touch screen, right? That is basically a sensor. And if you take example of your wristwatches, in the wristwatches we'll have a sensors which is going to sense the pulse of our nerve movement, right? The pulse it is going to detect. So like that. And one more example, temperature sensor. So temperature sensor will sense the temperature. So these are all the circuits, electronic circuits, which are going to sense the physical information. And then we have a ADC here. From the sensor, data will be given to the ADC. You know that ADC means it's analog to digital converter. This is going to convert analog data to digital, and it will be given to the processor. In the processor, data will be saved in the memory. From the processor, data will be saved into the memory, and at the same time, using programming, we are going to do the some calculation and manipulation. However, we require, we can do the calculation, and also we can do some processing on the data, and later data will be saved into the memory. And after that, if you want to perform some actuations, then we will passing that analog digital data to the DAC. DAC stands for digital to analog converter. DAC stands for digital to analog converter, and this DAC, or a digital to analog converter, which will convert a digital data to analog form, and later it will be given to the actuator. So why we require a digital to analog converter? So digital to analog converter, we want sometimes analog output. Best example is a mobile phone. Mobile phone output is a analog output. And if you take example of our television, the output will be in the form of analog. So some application outputs may require analog, some devices may require a digital. So that is why we are going to use the digital to analog converter here, DAC. So from the DAC we are going to give an actuator. Actuator is nothing but it is a mechanical device which is going to produce some mechanical output. Best example is a washing machine. In the washing machine we'll have a motor based on the DAC input, or based on the processor input. The motor will rotate clockwise and anti-clockwise, high speed or a low speed, like that. So like that, actuators are nothing but it's a device which will produce a physical movement based on the application. So in the embedded system, again further it is divided into a different small classification as a software and hardware. As you know that already, the embedded system broadly divided into software and hardware. In the software, again, it is subdivided into application, middle level, real time, and device driver. In the software section, it is subdivided like that. So we have application software, we have middle level software, we have a real time operating system, we have device drivers. So what is the definition of all this? Now let us try to understand in a one simple understanding. What do you mean by application software? Application software means a program which is specifically written to the application requirement. Best example is washing machine. In the washing machine, my intention or my program will rotate only the motor. My task is only to rotate the motor. I will develop the code to rotate the motor. I will develop the code to display the speed. Is called as an application. My application to rotate the motor. My application just to display the speed of the motor. If you develop the such code, is called as an application software. Okay, application specific, a coding or a programming written with respect to the application is called as application software. The second one is called as a middle level software or middleware we will call. So what do you mean by this middle level? Middle level is nothing but it is a bridge between application layer and device drivers. Because so sometimes we have to communicate to the application software from device drivers to application. Sometimes we may not able to communicate. Sometimes we can communicate directly or sometimes we may not able to do. In that situation, the middle software will come or middle level software. It's called as a middleware. So it is a bridge between application and software, application and device drivers. Then we have one more small classification, RTOS, real-time operating system. So this real-time operating system, nothing but this will give an instruction to the various applications which are running. I have 10 different applications and these 10 applications, how they have to run one after the other or based on the time or some mechanism. There will be some mechanism. So that logic mechanism will be controlled by RTOS programming. That is third one, and the fourth one is the device drivers. Device drivers are nothing but a code exclusively written for microcontroller components, like code which is exclusively written for memory, the code which is exclusively written for GPIO, or a code which is exclusively written for serial port, or code which is exclusively written only for processor. So that type of coding, the code which is written exclusively for hardware operation is called as a device drivers. Like this, a software is divided into a small classification, and this is how it definition looks like. Application software is a type of a computer program which is designed to help the user to perform some application specific tasks. And middle level software, and this middle level software it's acting as a bridge between application and the device drivers to interact, right? And then RTOS, I told you already, real-time operating system. So this RTOS or a real-time operating system will manage all the hardware and software components. Okay, and then device drivers, a software which is written to control the microcontroller components such as your GPIO and serial port and so on. So like that, so all together is called as an embedded system. So we have software and hardware. Under software we have application, middle level, RTOS and device drivers plus hardware. So in the hardware section, already you might be knowing we'll have a processor, we'll have a memory, we'll have a GPIO, and we will have a serial port. So in detail, we'll discuss later in the upcoming contents. So software, I have explained in detail about the software, but how to develop the coding for the software. So to develop the software or to develop the coding part, so we will be using C and C++ programming. So to develop embedded software, we have to we are going to develop the coding for coding in C and C++ programming. It is 100% true. Always we use C and C++. And also we will be using some compilers. C and C++ compilers we will be using to compile the program, and along with that we'll be using different IDE. So IDE stands for Integrated Development Environment in order to develop the coding. So these are all like software development tools. We'll be using C and C++ programming domain, and we'll be using a compilers, and also we'll be using IDE. IDE stands for Integrated Development Environment. There are different IDEs available like a Keel IDE, Cube IDE, MPLAB, and so on. Right. So this is how the software we are going to develop using the software like different tools. And coming to the hardware, so as you know that already, I have already told, we'll have a processor, we'll have a memory, GPIO, ADC, and so on. Right. So all these things we'll be discussing in detail in a upcoming videos later. So I hope this video is interesting to all. And if you like this video, please click on the thumbs up and subscribe my channel. So I'll come up with the next one more video. Till then, thank you.